Sorry about that. I had to load something else in, and then I don't think we're gonna get ads. Sweet, because I did it in the right amount of time. Hi everybody, I'm Wolftrove, and I want to learn what I want to do right now. And because I'm off work, this is what we're gonna try to learn. And so I have been learning on Godot. We've gotten up to level 12. Still trying to learn some things make sense to me, other things don't. And I don't know. I thought we'd just do this. Just which category for learning code? Software and game development. Okay. I'm just learning to code. So this is what we're gonna put it in. I gotta fix YouTube as well then. Edit this. Code. Function. Coding. Is it gaming? Technically. Learning code. Oh, no. This would just be software and development. No, it isn't like that either. Don't really have anything. Is it made for kids? Not made for kids. Do. Software? Developing? Developing? If I could word find, that would be great. That's better. Software and development. Stream language is going to be in English. I'm messing around. Canada. Save. There we go. Learning to functions code. Maybe I won't. Well, you know what? Ads in progress again? Really? Fucking Twitch. Stupid. That's fucking dumb. Why am I running two? Sorry, chat. I didn't mean that. The only person here is Max anyway. Hey, Max. Max, we're learning code. Maybe. Maybe if I can figure my shit out. All right. I'll wait to talk till the ads are over on Twitch, just because that's terrible. All right, we got 15 seconds, and then have a good day. All right, here we go. OBS scenes, we're gonna go to good. There we go. All right. Hey, everybody. Me, Wolfie. Okay, here's what we're gonna do. We're gonna turn off the Spotify because I only have 3 songs and I hear all 3 of them over and over and over again. The lovely gentleman at Pirate Software said that we could use the Heartbound OST as non-DMCA as long as I'm not doing anything promotional or anything like that on it. I'm just gonna use it for today because we're learning to code, and I don't know if many of you have noticed 2 weeks ago Drop Frames did a special with Pirate Software, the guy who made the game. This one, Heartbound. He's also a developer in a whole lot of things, and he's got a whole Discord and everything, encouraging people that, you know, if you want to learn to do stuff, that you should. And one of the things that he talked about was how to code with Godot if you can't afford like Unreal Engine and stuff like that. And so I've had 2 days off work, and I don't know what it's going to be. And I have an idea for a game that I want to do, but I don't know how to go about it. And the idea that I have is kind of like a mix mash between 2 other games. So I really enjoy Factorio and Satisfactory. Those are really great games to me, but also like Shapes is another good game. And like I have an idea for a game that I want to make for myself. I don't want to make it for other people. I want to make a game for myself, and if people enjoy what I do, then, you know, I might make it available to other people. But right now, I just kind of want to learn how to code. And so that's what I've been doing for the past couple of hours. It's just kind of learning and trying to understand how all these things work. And so right now, today, and this is what we're going to do. We're going to sit here. I'm going to learn. You guys can learn along with me. I will... I have it bookmarked, but I only have it for this page. Go back to Godot. And you can learn here. No, not here. Let's try that again. I'll post it. Open that lesson. If you guys want to follow along and do whatever you want, if you're into coding and whatnot, this is what we're basically doing. You guys essentially go there and start from 1, and you can learn to code if you want to. You can follow along, do whatever you want. Right now, we're learning how to use variables to make code easier to read. So right now we're doing the function. The process is delta. Delta is the amount of frames that you kind of want to work with every second. So right now, the number 4 under rotate here does mean how fast the character rotates. So we submit it. There we go. It rotates at 4 radians per second. So we can kind of guess the number that it represents by looking at the function names, but it's harder to recall what the number does by quickly looking at the code. We've seen different functions and they have their own names. Using names communicates to the developers what the functions do. So rotate parentheses 2 is rotate 2 radians. You can move local X by 100, which means to move horizontally 100 pixels, or to move Y down, you do minus 200. As we learned in lesson 8, we can also assign the labels to numbers to help us remember what they do. We call these labels variable. A variable is a label for a variable. For a value, we can save, change, and read later. So a variable is a variable name equal to the value. So we improved the first example to make it clear what the number 4 does. The variable is angular speed equals 4. This is the variable defined outside the function. So function process delta rotate angular speed times delta. So whatever delta is, I think delta is 0.5. So 0.5 times 4. That's how that works. On the above example, which line defines the angular speed variable, which is the rotate angular speed times delta? No. Oh, sorry. That is the speed. I was going too far ahead. So we create the angular speed variable assigned to the value of 4. So that means every time that we go into this process and we type in angular speed, the value will be 4. And it's just a quick way of saying, okay, angular speed equals 4. Because any function can use variables, we define them outside. We can call these variables script wide. Here we use angular speed script wide variable in both the process and function and the set speed function. So the variable 1 is variable equals 4 function process. Rotate the angular speed times delta, and then set the speed, new angular speed. Angular speed equals new angular speed. Okay. We can also define variables inside functions. We align the variable assignment, indenting, make it part of the body function. Make sure to create the variable before using it. We define the variable inside the function, only the function can. Okay. The function is to process delta. The variable is angular speed equals 4, rotate angular speed times delta. And function set angular speed at a new angular speed that equals the angular speed variable exists inside the process because we defined it there. Set the angular speed function, not use it. And trying this will result in an error. Errors are a good thing. This is how you learn. Here's what the error might look like. The identified angular speed isn't declared in the current scope at line 6. Why this happen is set the angular speed function cannot use the angular speed variable because it isn't script wide. It also isn't in the how do you fix that? Make sure you define angular speed variable in the set angular speed function or define it outside the function scope. Where can we define variables? You could define them in and outside, yeah? Yes. Okay, perfect. Variables are also great at grouping variables that control how characters behave. Grouping them in this way allows us to easily change them. So, variables to control movement. Variable horizontal speed is 200, jump strength is 150 gravity. Variables for combat. Health is at 40, health maximum is at 80, attack power is 10, defense is 4. In the following practice, we'll define variables and use them with familiar functions to make our code readable. Yeah. Clarifying the code using variables. Let's give 4 here a label so we know what it does. Create the variable called angular speed. The variable angular speed outside. Okay. Oh. So I'm gonna need a hint for this because I don't quite understand. At the top of the script to make it script wide. Process delta. Angular speed. Process angular speed. Oh, well, maybe I don't understand. Alright. Reset this. I'm going to use the variable of copy. That work? No, clarify code. Okay. So if I put it there, would this now change? Okay. The angular speed has a value of 4. Don't forget to use the... Find the variable, use var equals 4. Oh. So... I use var angular speed equals 4. Alright, I'm gonna have to look this up because I don't quite understand. So you want the first function to be a variable. And then you do angular speed equals. Then the function like that? Oh, okay. So to make it script wide, I had to use the variable first, and then later in the function use this, so that the variable comes first, so I don't have to use the number 4 in the rotate. Oh, okay. So for funsies, we would go like this, go variable angular speed equals 4. Come down to 4. Change that to 8. You would run that, and that's how that works. Awesome. Okay. There is something wrong with the code here. Can you see what it is? Run the code and read the error, then. Okay, so the angular speed has a value of 4. Shouldn't that be up top? Ah, ooh, Wolfie. That was heckin' good, spin your little boy just then. Yeah, I kind of want to learn because then I can do stuff, you know? How's it going, Erasmus? Alright, so I'm pretty sure that this function or this variable has to be up top so that we know what it does, right? And you get rid of that. So it runs the code. Okay, so that's all it was that the variable that we needed for everything else had to be up top so that we understood what it did before we did the function. All right. Conditions. In previous lessons, we decreased or increased the character's health, but there was no limit how much health they could have. So in here, function take damage is equal to the amount. So health is minus the amount. Function heal is health plus the amount. Okay. As a result, the player could increase the character's health indefinitely. Heal, as you can see. But do you know why that was important? It was important because 4 was the value of the variable, but if we put it at the top, it then makes it part of the library, telling them that the angular speed becomes the primary variable. So it was gotta work for memory now. Angular underscore speed equals 4, but you put the variable in the front, so that becomes a multi-variable that you can use later down the line. So as long as that's in the first part, you tell the computer, okay, the variable is the angular speed equals 4, and then you go down into the function to tell the computer, okay, we want to do the process of delta, and then under that process is equal to rotate the angular speed times delta. So that tells the computer, okay, we want you to run delta, and we want to run delta at the angular speed that is 4 times delta. And then at the very bottom it said new angular speed. We could then add a new angular speed in to the next function when it comes time to do it. Thanks, Erasmus. You're helping. You really are, because I wouldn't have put it into words to help my brain understand it until you asked the question for me to know why that was important. Oh, do you know why that was important? It was important because you need to have the variable to do before when it was under the function. We were trying to do the function and add the variable, and the variable wasn't there for the computer to understand what was going on, because the computer is very basic. All right. What happens to the health when we damage our character? The character is supposed to have 100 health. What would happen if we called take damage 25 5 times? We would have minus 25 health. We would subtract 125 from 100. We can use conditions to run selectively. Condition to make our code branch and tooth path. If a condition is met, the computer will run the corresponding instruction. Otherwise, those instructions will not run. Video games and other computer programs are full of conditions. For example, the game input largely relies on the conditions. If the player presses the button on the gamepad, the character jumps. Jump, motherfucker! So when the computer checks the condition, this is called to evaluate the condition. All conditions evaluate either true or false. Either the player is pressing the button or not. Either the character is touching the enemy or not. In this case, if health goes over a value, we want it to reset to. To define the condition, we use the if keyword when writing the line starting with if. So type the condition evaluation at the end of the line of the code. Okay, so the function is to heal the amount, and then this makes this function run. So health plus the amount. If health is greater than 100, health equals 100. Health is 100. Notice we use the comparison sign. We will read the symbol as greater than. Yeah, so if health is greater than 100, set health to 100. We've seen how functions define use the colon at the end of the first line, nest content inside. In GD script, this syntax is a recurring pattern for all code blocks. The computer knows which instructions belong to the condition because they are intended. So health is 75, is 125. Okay. Set. Heal 50 equals 100. Erasmus, how you doing today? You having a good day? In the above example, we use the greater syntax to meet greater than. We compare the numbers in other ways too. Greater than, less than, equals to, not equal to. Okay. So here's how we might use if statements. If the health is less than 100, or sorry, greater than 100. What? If health is greater than 100, pass. If health is less than 50, pass. If health is equal to 25, if health is not equal to 7, pass. Okay. Pass is the keyword that prevents errors in our code and the line cannot be empty. For example, you must have a line of code after a function define definition or if block. You know, when you don't know what to write, you can use pass keyword and won't give you any error. Oh, that's nice. Okay, so if I don't know what I'm supposed to be doing, I can write pass as a placeholder. Oh, that's kind of neat. In previous example, if there was nothing below the if lines, could not would give us expected identifier block. Okay. So which of these statements are true? 1 is not equal to 3. 2 is less than 3. 2 is not equal to 1. 3 is greater. No. That, right? Yeah. So the comparison is 3 is greater than 1. It's true. 2 is less than 3, which is true. The comparison 1 is not equal to 3. Pass coding. What? Panacea? Panacea. Or else if it completely elsewhere. You could also write else in the block if and then if block. So what? So step. Your speed is 120. If speed is less than 100, you're fast. Oh, so if my speed were under, you're slow. Okay. Okay. Your speed is 120, but if your speed was less than 100, print you're slow, else print you're fast. Pass is a coding panacea. Got it. The else block will run whenever the condition isn't met. The following practices will use conditions to help improve our character's health changes so it has limits. Alright, so the function is health. The variable health is equal to 100. That is true. If health is less than 5, print health is greater than 5. Okay, so in this series of if statements are all wrong, change the comparisons so each comparison matches the instructions below it. Keep the variables in the statement only if the... Well, I'm changing them, right? Health is equal to health. I think I got it. Yeah! So the first statement is true. If health is greater than 5. Greater than. Oh, I know this one. It's the 2 doors puzzle. One statement always lies, and another statement always tells the truth. You remind me of a skit that I saw. I think it's Padookles or something. It makes me laugh every time I see it. Oh, I should find it. Limiting health. The goal, we have a heal function that adds the amount of the character's health. Add to the function so the character's health is never greater than 80. Okay. So if I ran it, that would be 100. Health limit is... The hints are, you can use a condition. So we could do like if health is greater than 80, this is not gonna work. Why? Because I'm dumb. I don't know what I'm doing. If health is greater than 80... Fuck, I forgot what we just learned. You're freeballing code like a champ. Right, but the solution's right there. Like, I could click it if I don't understand what I'm doing. But I kinda... I want to figure it out, but at the same time, like, it's hard because I just learnt what we were doing, and then I forgot all about it. So if health is greater than 80... Find this for me. Health 80. Nope. Yeah, fuck, I don't. Alright. I was close. I was really close. That's the answer. So function heal amount, health plus amount. If health is greater than 80, health is equal to 80. Nope. That's apparently not how you... What? What did I read wrong? I did it the wrong way. Son of a bitch. There we go. Oh. I don't know if you saw it. I'll just pin this to the top there. There's also a less efficient way. If health 80 pass, else health is 80. Oh. Yeah. I'll just pin that to the top there. This is the program that I'm using. And you can go. I'm pretty sure that you yourself could just like ace the whole test. But okay, so when the robot takes damage, health can be negative. I ran that. I can't do anything. We might want to display the health number on the screen like in Japanese RPGs. We don't want negative numbers, and we want to stop at 0. So, if health is less than 0, health equal 0. Yeah? Nope. What do you mean? That should be right. We just learned this. No. If health amount if health right? Damn it! Is this wrong again? Nope. Just dumb. You can use a condition to check to see if health goes below 0. You need to increase the health by a certain amount. Health is equal to 0? Hello, Max. I could play it long, but I'm trying to catch up to Zerk and Vonx in FF14. If I had to make a new character on a server and actually get leveled, isn't allowed to. Yeah, that's what I found too. I think mine lapsed, so I don't give a shit anymore. A coding wolf, yeah. I'm trying to code. If health were equal to 0, health equals health. Else or would it be this way? Nope. I don't fucking know. Oh, okay. Alright. I see what I did here. if health was less than 0, then do this. Oh, do that. And health would equal. Alright, let's see if I can understand why I did this. So function is to take damage of the amount. If health minus the amount, if health is less than 0, or bullet point, health equals 0. This is still wrong. Ah, why is this wrong? We? The fuck? Isn't this the same solution? What did I fuck up? Reset. Health is minus the equal amount if health less than 0, health equals 0. Oh, now it fuck. Oh, because I put a space in between these two, and then it didn't work this time. What? This clearly shows a space. I didn't put a space, and this somehow worked. It doesn't matter. Okay. There was an extra space for the first. Oh, shit. I might have done that. Okay. Guys, I'm terrible, but I'm learning. Mistakes are learning. And I make a lot of them because I don't quite understand what I'm doing. Level up. Our robot's health is always 0 and 100. When our robot fights, it wants to increase strength and toughness. When our character levels up, they deal more damage to enemies, gain new abilities, in our case, gain more health. We define level variable. Keep track of the level of the robot. The level starts at 1. So variable is equal to level 1. When the robot has defeated enough enemies, we call the level up function to increment the robot's level. So the variable level equals 1, but when the function level up is called into play, we do level plus 1. As we briefly saw in the last section, our robot can range variables that increase when it levels up. So the variable of health is equal to 1, max health is equal to 100, power is equal to 5, defense is equal to 2. In this lesson, we'll focus on increasing the robot's maximum health. The variable of max health is the maximum of the robot's health can be. Change our heal function to this variable. So variable health is equal to 100, our variable max health is equal to 100. We can heal the amount, so health plus the amount. If health is greater than max health, health is equal to max health. Right? Oh, Max, like way back here, like what is code? Your first error, drawing a rectangle, all that stuff was hard as well. Like none of this is easy, but it's helpful. It's helpful in a way that, like, yes, there are times I don't really understand what I'm doing, but at the same time, even when I do the solutions, like I could turn around and I could go back to 1 and start over. I still might remember everything that I did, but once I complete this, I'm gonna go through it again and again and again, and I'm gonna learn over time, because A lot of the things I've been told is you can do this. You may not learn how to do anything in Godot, but take 3 months and learn and learn and learn. And so this is what I'm trying to do. This is going to be a very rough start to a thing that I want to try to do. I'm going to do most of my programming in Godot. I have an idea for a game, and it's a mash of my 2 favorite games. Now, when I make this game, am I going to sell it? Probably not. I'm making the game for me. I want to make a game to make me happy. And I have an idea for a game to make me happy, but nobody's going to make it. So, I'm going to learn. I mean, yeah, that's what it is. Factorio dating sim. There could be bears in this game, but Max, you're going to have to do the art for the bears if you want bears to be in the game. It's going to work. No, I have, like, I'll show you. It'll be easier if I showed you. Okay, so in my library, I have this game called Shapes. And I will show you Shapes. This is what Shapes is. It's a game about shapes. And you can cut the shapes up and make different things all you want. And then you can rotate them and then cut them again. Then you can rotate them, and then you can stack them on top of each other in order to make new shapes. And you can also paint them different colors. This is all fantastic, okay? This is not the kind... Well, this is kind of what I want to do. But I want to do this in a different way. So this is a game about making different shapes. Alright? I want to use the kind of same starting thing as shapes and add it to Factorio. So in Factorio, you have this copper ore that you mine from this. So imagine if we took copper itself and put that into shapes, and then you had copper come down the line, right? And you just have 1 copper per belt. And then we got to a smelter, so then you put it into a thing with, they're using coal at this point, let's say wood, and then we made bars. And then you put that into the central hub of shapes. You know what I mean? Like, I'm only making the game for me. It is a mashup between 2 of my favorite games. This is all I want to do. But I want to make the game more and more complex. So instead of just adding copper and iron and steel, I also want to add other elements to then make other things. And then I have to look those things up. But right now, all it is you would be mining copper, and then the copper goes into a central hub. I'm copying Pirate right now. Pirate software. Because this is what he does, right? He draws things in paint. So new. So we take a thing. And so you're just gonna mine this out. This is copper. Then you mine it out. And you put it on a belt that goes in a direction. Okay? That direction. And then we're gonna have like a hub. Right? And so this is gonna go into the hub, and then hub is gonna make research points. Those research will then unlock other things. Do you understand? Like, I suck at paint, but that's what I was thinking. And yeah, that's the kind of game that I want to make for myself. Will it turn into anything? Probably not. No, don't take that out. Take that out of your mouth. He seems like a really decent guy, and you know, he does want other people to help, and that is amazing. We should all do that, right? And if there are coders like Erasmus that come out and be like, hey, by the way, you could also do this, that is helpful. I kind of want to learn. And because I'm not doing anything at work at the moment, I might as well learn this. And then in my spare time, I will learn to code. And then maybe make something for myself. But we got distracted. I have no idea what we're doing anymore. Alright. So we're talking about this robot. Also, by the way, all this music is from Pirate Software's game Heartbound? The Heartbound? Heartbound. He said that you can use this. Any streamer in the world can use this as long as you're not doing stuff. Where does Max's leather daddy brown bears fit into the Copper Smelter Hub research gaming pipeline? What if you could unlock the research to get helpers? And the helpers were the bears. And the bears helped you make the leather to carry the pouches that brought them. But the only way to you could get your first bear from research, and then if you wanted to make more bears, we would have to do bear things, and we can hide that behind a privacy filter, and Max can be the only one to watch the bears fuck. All right. I don't know how bears fucking make other bears, but you know, it's a game for Max. All right. We have 9 minutes, and then I'm gonna take a break and go get water and stand up and do stuff. All right. In this lesson, we're gonna be focusing on increasing the robot's max health. The variable max health is the amount of the robot's health that can be, and we can change the here function. So, the variable of health is equal to 100, and variable is max health is equal to 100. The function, the heal the amount plus the amount of health. If the health is greater than max health, health is equal to. Okay. We could add 5 to the max health every time the robot levels up. So in the function level up, level plus 1, max health is plus equal to 5. This would increase the max health the same amount every time if we grab. How many? Boom. Got it. I'm already having ideas. The bears don't actually have to do anything. They just walk around your factory and randomly seductively dance. That kind of entertainment of Roller Coasters Tycoon if the entertainers were slutty and also bears. Alright, so I have 3 people in my current game development team. Erasmus is currently the guy with all the ideas. Max is the one modeling bears, and I'm writing code for some stupid reason. I can see this company going places. This growth is linear. In our case, we want feeling of more power as the robots level up. Okay. So then this is exponential growth. With each level, more max health is added than the previous. To get exponential growth, we multiply the max health by an amount greater than 1 each time the those robot levels up. What? Goldmine, lads. We're in to win it. Now, my ADHD brain just needs to go, okay, this is the game we're making, no changes. Sure, it will level up great. Oh, what is the value of damage? The variable level is equal to 5. The Valorant power is 3. Calculate damage times power level. The damage is 15. Okay. So we can use the multiply in the same way that we use the add and subtract. What is the damage now? So if the level is equal to 5 and the power is equal to 3, power times level, times 30. Yeah, because it's 15 times 2, which is 30. That totally made sense to me in my head. I just couldn't say it out loud. 5 minutes. So let's level up our robot and add exponential. Fuck it. We're adding stuff. Okay. So the variable level is equal to 1. The variable max health is equal to 100. The function, the level up, level plus 1, max health times 1.1. Okay. Let me look at all this graph to make sure I understood what we're going to do. Let's go in here. So the level up is going to be level plus 1 and then max health how do I do 10%? Is that plus, or this would be plus yes? Correct value is incorrect. Alright, well I fucked up somewhere. To increase the number by 10%, multiply it by 1.1. Okay. So we would have to multiply this 1 by 1. Yeah? Okay. That does make more sense because we just learned it. I just wasn't sure if math. Okay. Do you know what? At least I didn't use the solution in order to figure it out. I learned from my own mistakes. Congratulations. Alright, so the level of our character currently is 3. Our health is equal to 100. Our max health is equal to 100. We are going to take the damage of the amount. Add take damage function. If the robot's level is greater than 2, reduce the amount by 50%. Okay. So we would have to do if level equal to 2, amount is divided equal by half. Like that? Nope. Oh, sorry, my bad. I fucked up. If level is greater than 2. Round. Nope. Why is that not what we just discussed? Exactly, progress. But this is not. Oh. What if we did if 3 is greater than 2? It smells in here. The fuck am I doing? Alright, I already fucked up. So I want to do the variable of level is equal to 3. So if level is less than... No. Wouldn't this be... Nope. I don't fucking know. Oh, okay. So this has to be over here. This is if level is less than 2. This is times. No, I still fucked everything up. Reset this. Okay, so if level 2, then amount divide by equal 0.5%. Else like that? Nope, this is still fucking wrong. If you reread the task again, this one's tricky. Alright guys, there's currently an ad. I'm gonna take a 3-minute break. Next time I'll be sure to put in my beer back screen so everybody knows what's going on. That should make sense though, doesn't it? Oh, I keep forgetting the 2 dots. And then apparently that's not what? Oh, we gotta do the extra indentation. And then that's fine. No, I don't need else. God damn it. I thought you died, but welcome back in any case. Nah, I was taking a 3-minute break because you guys got ads on Twitch. YouTube didn't, but the solution's still not right. No. You gotta times it, not divide it. Alright, well that was fucked up. I didn't really learn anything there. I don't think, other than to stop using else when it doesn't tell me to. Good on you, Max. You take your power nap. Suppose we wanted to increase the size of the robot when it levels up. You may recall doing this when using the following code. Scale x plus 2. We talked about it in lesson 7. Scale is the variable of 2 sub-variables x and y. Because the scale is a vector 2, stands for a 2-dimensional vector. Vector 2 represents the 2D coordinates. Vectors are the physics and the quantity of the magnitude and direction. For example, forces applied to an object, the velocity and speed of direction of a character is so on. We often represent this with an arrow, and got 2D vectors are common value, named vector 2. Unlike plain numbers, they're stored in 2 decimals. So this is 0, 0, 0 minus 1. This is minus, that's plus minus, plus plus, this is... So far, you've come across 2 variables in the course of which vectors? Which are they? Speed and position? Nope. Scale? Nope. Health? All of them? Nope. Not position. Not speed. I don't fucking know. We've done scale. Okay. Velocity, speed, and direction. Scale and speed. Scale and position. Sorry, I'm eating peanut butter and jam sandwiches. Vectors are essential in video games. Allow you to represent the character's movement speed and direction, calculate the distance to target, and more. A little code. Take this AI turtle. You've probably seen them where enemies move like this. This is done with just 7 lines of pure vector calculation code. The code is a bit too difficult for now, so we'll spare you the details, but this turtle gives you a glimpse of what 2D vectors can do for you and your game projects. We scale the robot again, this time by adding to its direct to variable. Stand's kind of lower. Following the same effect as previous example. So in the function we are doing the level up. Scale plus vector 2 to 2. Notice how we use parentheses in the 2 arguments inside the parentheses, just like creating the particular of a type of act. The code is .2.2. Constructs a new vector. The value x set is. We can make bigger copper nuggets, and then when the level. Oh, we could do it like a mine industry, because they also do that. How would you move a robot 50 pixels to the left? Hold on. So if we wanted to go to the left, it would be -50. But there's no -50 here. But I think this would be minus. Nope. What's the difference? Position. This one is position X. What's the difference? Tries to subtract the 2D from the. Incompatible. When you try to do this, you will get an error. Oh, okay. So I don't need to add position X to minus the vector. Okay. The position. Oh, it's vector 2. Yes? Oh, wouldn't this be level? It's greater than 2. Nope. Hmm? I figured it out. Resetting the size and position. That one was getting tricky. This one's getting worse. Because now I gotta write all my code. Nope. Function. Reset. Robot. Colon. The subvariables of the robot scale need to be 1.0. This robot's position needs to be exactly vector 2. Fuck. What was it that we used? It wasn't scale, it was move. Move equal position. Nope. Excuse me. Yep. Okay, that didn't help at all. What if it's position equals vector 2? No. Scale. Oh. Position. Ooh, I got 2 of them. Nope. Hmm. Nope. I'm not scaling the robot correctly. You're close, though. I can feel it. Scale value is 5. It should be 1, 1. Oh. What if I minus this? Minus by 4 point. Minus this by 4. Ah! Nope. Ah! I did it! Ah. So I was sitting there and it was like, what? What is going on? And then I looked at the errors and the errors told me that they were 5.154. I was like, oh, shouldn't I just minus? Not the intended solution. So I got there. I beat the system. All right. So what they wanted me to do was reset the scale to vector 2 of 0, 0. Or sorry, 1, 1. But what I did was I just reduced it once. Oh fuck. So technically, I'm right. technically that's what they want. All right, let me do that again. It would help if I actually did stuff. Reset robot, parentheses, colon. And we want to do, oh, I'm gonna hide the solution. Scale equals oh no, I already forgot. Vector 2 1 1, and then position equals vector 2 0 0. Aha! I figured it out. Technically, it reset a function you wrote, but only if the robot scale is exactly to meet never another value. Right, but when I was doing this, it told me the scale was 4.154. And so that's the only way I knew how that I could reduce it. I didn't think by taking this away, I could just set it. I didn't think that. Oh well, we did it. Completed the lesson. So now if I want to set a scale of something back to a certain vector, that I could just go equals that vector instead of saying minus whatever the error tells me. Okay. You've seen that functions can reuse code. In this lesson, you'll learn about loops. Loops help you repeat code. Illustrate how loops work. Let's make a game board split into a grid. Our robot can move in the neighboring cells by changing the vector 2 variable named cell to represent the current cell the robot is in. We increase the cell point X, the robot moves to the right. Note that we delay our robot's movement in the app to help you visualize how it moves. The following code would normally have the robot move instantly. Okay. We can move diagonally by adding to the vector. So, move to the right, the cell is point X plus 1. But if you want to move it diagonally, you would remove the vector. Oh, okay. The above code works for a predefined board with a size vector of 3, 3, but the move to the end function wouldn't work if the size of the board was different. Oh, move to the end because vector is okay. Yeah, that was the catch. It was the equal. It's checking for conditionals, whereas equal is setting a value. It's a good thing that you're here because I just would have powered through this and I would have went, I wonder why I didn't fucking learn it. I guess I gotta take the test again. Here's my other thing too, okay? Reading's hard for me. It really is. And if I try to read on my own time, I will get distracted. And I won't complete very much. And it's because the things aren't interesting. If you can make something interesting, I'm more likely to read it. And the way that I go about doing that is I listen to audiobooks. And there are a lot of people out there who say listening to a book is not reading a book. But it is. I'm just using a different sense than the one that you assume reading is. Because, and I will say this for anybody listening, if you are reading a book with your eye, you are using your eyes to read stuff and then visualize that in your head, which is good. It is very helpful for a lot of people to do it that way. If you were blind, you would use your hands, which is another sense, which is a tactile sense. You would feel the braille and do the same thing, where you would visualize it in your head, even though you wouldn't necessarily know what you were visualizing, because you have no reference, right? I'm sure you could make a reference in braille to help people understand what is going on, but their interpretation of what they are seeing would be different than yours, just like everybody else. Whereas I use audiobooks, so somebody else talks and then I take the words and make them the way that they are in my head. And so it is easier for me to listen to an audiobook than it is for somebody else who reads a book and can do the same thing, right? And so that is how we're all different as people. So this is really challenging. It is really challenging for me to sit here and read all this stuff and then comprehend it. It would be different if Erasmus was telling me everything that I needed to know and then I did the stuff and then I could probably do better that way. That is not how this is made. Or if it is, I haven't looked. Hey look, it's in 60 FPS. Let's make it no limit. I also have to put music on when I'm reading the code. Yeah, it helps take your mind and put it in another spot. That way you can use the maximum power that you have while another part of you is moving. So it's kind of like RAM. Alright, so I don't know where the fuck I was. To implement a general solution to all board sizes, you can repeat the robot's movement until it gets to the end. Code repeats. You can use loops. While using loops to repeat code, you can use a loop to make the computer repeat a block of code until you met a specific condition. You either decide to break from the loop. Here's how we use a while loop. So the variable number is equal to 0 while the number is less than 4. Print the number. Number is 1 plus 1. So the variable of the number is currently equals 0, and then you add plus 1 until it comes out of being less than 4. We use the variable number to keep track of how many loops while in the loop completes. While loop completes. Each time we go through a while loop, we add the number 1. While the loop keeps running, for as long as the condition is true, in this case it'll keep running unless the number is not less than 4. So 0, 1, 2, 3. Nice. Good job. Oh, that's how you make it go through everything. Okay. Let's apply this to the move in function. This time we compare the number of loops in the board width. We go through the loop till we reach the width of the board. Note that when we move the robot's position one less than the board's width, we are counting from 0. The board is 3 cells by 3 cells, so the coordinates are going to be 0 to 2. Both the x and y axis. Number go up. We vampire surviving now, baby. So function move to the end while cell point x is less than board side x minus 1. Cell is plus... Oh. Oh, alright. While loops can cause issues if you're not careful, a while loop can run indefinitely. In that case, the application will freeze. We'll take a look at this code example. The variable number is equal to 0 while number is less than 10, draw a square. What would happen if the computer tried to run the code above? It would draw squares indefinitely until the program is terminated. Because we don't increment number within the loop, it will always stay at 0. As the number is always lower than 10, it will never break out of the loop. Since there is no exit in the while loop, the computer will attempt to draw squares infinitely until it freezes a break. When the program stops responding on your computer, it is often due to an infinite. Okay, so in this particular one, we would do variable number is equal to 0 while number is less than 10, and then we would go back here and say print number is equal to 1, and then you would put draw a square. You would put the draw square here, right? You would put draw square underneath this, and then print number. I think that's how you do it. At first, you will not need while loops. Often, even when the code when we show here has the most efficient alternatives. There's also a safer kind of loop for loops. Which we will look at in the next lesson. Yet while loops have an important intermediate and advanced level uses. You at least know they exist and how to use them. We use while loops every time we need to loop an unknown number of times. For example, in a game, the loop that typically generates 60 images per second until the user closes the game. This is possible thanks to while loops. There are other good uses for while loops: reading and processing a file like a text document line by line, processing a constant stream of data like someone recording audio with a microphone, reading code and converting it into instructions the computer understands, various intermediate advanced level algorithms finding paths around or map. Let's practice some while loops. They're useful to know and an excellent opportunity to practice 2D vectors. Then we'll move on to safer for loops following this. Move to the bottom. As. Alright, I'm definitely going to need hints for this because I forget already. So, you're going to go cell dot y minus 1. Oh. Hold on. This is 1, 2, 3, 4, 5. You forgot. Like, this is terrible for me. Oh yes, we're using while. While cell dot y less than board size y minus 1. This is broken. Nope. That is unneeded. Oh, I was close. I didn't quite get it. Okay. So cell is plus equal vector to that's got to be here, right? Okay. Stay, let's look at this some more. So we wanted the function to move to the bottom while cell y is less than the board size y minus 1. The cell we want to add to is the vector of 0 plus 1. Yeah, you gotta remember indentations too. Some program you need them, others you don't. I mean, it is difficult, don't get me wrong. Like, maybe I should have looked more at the documentation to help me understand what I was doing. But this one I didn't quite understand, just purely for what it is. I'm going to continue moving on, even though best thing for me to do, but I will learn by brute forcing everything, and then I will go through and I will do it again, and hopefully I can start remembering stuff. I think the other problem is, like, I don't write anything down. It's all memory. Yeah, it's terrible. So in the last lesson, we looked at while loops. Found them useful. We don't know how many times we should repeat code. However, they could result in infinite loops if we're not careful. The loop below never ends because we never incriminate the number. Yeah, there's a whole lot to remember. And I'm not going to do this in a day. I'm not going to figure this out in a day. I get that. I understand. But I'm still going to brute force everything I got. That's the kind of rogue that I am. There's a safer and easier kind of loop, the for loop. We'll look into it at this lesson. Unlike while loops, for loops don't run indefinitely. So it is much less likely that you'll get bugs in your game. We recommend favoring for loops over while loops because of this. You smart little cookie. Not in one day, maybe 3 days tops. Thanks, Erasmus. Let's change the code above for a for loop instead. For number in range of 3. Cell plus vector 2, 1, 1. So, if the grid is of 3 squares, each cell is going to move 1 by 1. Godot has a helper function range, calling the range n. Creates a list of numbers from 0 to n. That's 1. So calling range 3 outputs the list of numbers of 0, 1, 2. And the range 5 is 0 to 1, 4. What print range 6 would print to the console? 0 to 1, 5. Yeah. That makes sense. I get that. So for a loop, the computer takes each value inside a list and stores them as a temporary value and executes the code in a loop once per value. So you want the function to run for number in range 3 print number. Print 1, 2, 3. Got it. In the example above, for each item in the list 0, 1, 2, Godot sets a number to the item, then executes it in the code. We'll explain arrays more thoroughly in the next lesson, but notice the number is just a temporary variable. You create it when defining a loop, and the loop takes care of changing its value. Also, you can name the variable anything you want. The code behaves the same as the previous example, so run for element in 0, 1, 2, print element. Oh, okay. So we could do it that way, or we could do for number in range, print number. But we could also do for element in range 3, print element. It would still work. Okay, that's good to know. Godot moves through the loop and assigns each value for each array to that variable. First, it sets the variable 0, then to 1, then finally to 2. We can break down the instructions when the loop runs. You can see the loop the variable is the array. The array is 3 arrays. And then the element is null. The element is 0, print element. That kind of makes sense, right? I'm sure we'll figure it out. We can put together whatever code in the loop into the code's block using a function called draw rectangle. Using a loop, a for loop instead of a while loop. Here's our old move to end function in the while loop. While cell x is less than board size minus 1, x cell is plus 1. For a loop, instead, the code becomes a little bit simpler. For the number in range, board size x minus 1, cell x plus 1. So if it is of 9, this would be the number in range of the board size minus 8, or minus 1, which would be 8. The cell would then move up 1. And then stop. In the practices for loops in different ways, you'll get used to them. Alright, let's see what we can move to the bottom. 4. Oh shit. Lost it. Damn it. You see how difficult things are for me? Like, for number in range board. Okay. For number in range board size dot y minus 1 cell plus y plus 1. Right? It done fucked up somewhere. Oh! Did that? Nope. Oh, plus equal vector to nope. You don't like this. Nope. If the line of code errors right after the line of colon, la 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 la. Yes. In practice board 4, at line 3, bottom, column 1. In other words, your line should have more than one leaning. What? The subvariable cell to move downwards. And that is right, isn't it? Nope. Nope. 4 needs the lines after it to be indented. Well, that wasn't my only problem. One problem solved. No, we're inside that loop. Ah, it still doesn't matter. I did use a loop. I didn't get it from the bottom of the board. What if I did that? Change that. Nope. Robot isn't at the bottom of the game board. Did you increase? What if I minus it? Achievement. Yeah, brother. Can I have some loops? Fuck's sake. What is it? Really? 4 number in range, board size y-1, which I got. Cell plus vector. Zero. This is 1. Is that because X is X and Y? The robot gets to the bottom. But why? But why? Don't understand. But I didn't need the cell is +1. My brain hurts. So the robot's starting cell is vector 2, 0. So 1, 2, right? That's oh wait. 0, 1, 2. Okay. Damn it. Oh. It's gonna be a long time before we can make this bear game. Tell you what. Alright. Use a for loop to remove the duplicated code in the run function. In this practice, we revisit the turtle drawing rectangle. With our new knowledge of for loops, we can condense this code to take up less space and make it easier to modify. The turtle should draw 3 squares and a horizontal line. The squares should be exactly 100 pixels apart. Should do this and go 4 in range. Delete all of that. Run. Nope. Got something. For number in range. Nope. You will get this error. You wrote something that was synonymatically invalid. You are missing something in the previous line of code. Yes. I know what it is. That thing. Then indentations. Run. Haha! I figured it. Another 3-minute break, everybody. Take them if you got them. I'm still here. Just we're gonna take a break. Because definitely people need it, especially me. And you know what? I'm actually